I need you guys to keep tabs on me. I keep forgetting doing this. There we go. Okay. So before we go on with the runners example, I want to talk a little bit about field access now that we have seen higher order functions a little bit. I must admit, I wasn't the clearest in class when, or at least I feel I wasn't as explicit as I could be in kind of giving you the nuance of what you can and cannot do and why should you obey those rules. And as I said, with higher order functions, kind of mucks it around a little bit more. So as an overview, what fields can you access? This question has come up several times in class, during lecture, on Piazza, and so on and so forth. So, field of field. Field of field. This is strictly not okay. This is never okay. All right. Now, field of parameter is when things get murky a little bit. Okay. And here's where the nuance is. So there are two cases. If type of parameter is the same as type of this, then it is okay. All other cases, not okay. Avoid if you can. I won't write it there. I'll write it as a special case later on. Okay, so there's the nuance. The rationale for this is that think of the fields, you define the fields as part of a class. And so in some sense, one object of that class should be able to access the fields of another object of the same class. And that is what I mean by if type of parameter is the same as type of this. And an example we took was, the very first example was whether two books have the same author. And so you have this, and that method had a parameter of type book. And so there it is okay to say other.author because you are accessing a field of a parameter, but the type of the parameter book happens to be the same as the type of this. Okay? So in that case, it is okay to have fields to access a field of a parameter. All the other cases, it's not okay. And we have seen several times how to get over this limitation. You write a helper in the class itself that will do what you intend to do with the field. Okay? Now, the reason I bring this up now is because last time we wrote these predicates. We yanked that method out of the runner class and put it inside another class. Okay? And right here, we said r.pos. And so R is a field, R is an argument of type runner. We are not in the runner class, so type of this is not type of runner, type of the parameter. And yet we access r.pos right here. So we seem to be breaking our own rules here. And while you should still avoid this, we did this here. And part of this is kind of a consequence of writing higher order methods, because what we have done is we have broken sort of another one of our design rules just to be able to write higher order functions. How did we do that? Initially, this was not here. The method that told us whether this runner was in the first 50 positions was written in the runner class, where it technically belongs. That created other problems, as we saw. It stopped us from abstracting and led to a lot of duplicate code. So we yanked it out. So that's where we kind of sort of broke our design. And that resulted in the need to do something like this. Okay? It is still possible to avoid this. You can continue to have that method in the runner class that we wrote before, and then call it here. So we could say r dot is within position 50, that helper that we used to have in the runner class. So you can still employ that technique to avoid a field of parameter access. Okay, but in this case, I just wanted to point this out because we did break this rule over here. And it doesn't matter whether we use lambda function notation or not, the same problem occurs everywhere. Okay, and so yes, we did this, and yes, that was a temporary breaking of the rule. You can avoid this by once again writing a helper method if you can inside the runner class. Okay, does that make the rule clearer? The field of parameter, if the parameter type is the same as this, field of parameter access is okay. Otherwise, not. All right. So with that, let's continue with let's run with the runners example. So we wrote a method last time that ended up being a filter, the find sum method. All right. Now, there are other methods where we saw roughly the same problem. So once again, I take you back in time to ILO books. And one of the methods we wrote was sort this list of books by price. Okay, we might want to do something similar here. It's a list of runners, and we might want to sort this list of runners by their finish times. So finish time, as you can see, is one of the fields of the runner class. And so surely we can write a method that sorts this. And so just as a review, we have seen this several times. We used an algorithm known as insertion sort for this. And so we said public ILO runner sort by time. And how do we get the sorted version of this list? The sorted version of this list is obtained by adding this runner in the sorted version of the rest of the list. Okay? And so this led to the following straightforward implementation. First, you sort the rest of the list by time. And then in that sorted list, you insert in the order of time this dot, did we call it first? First. Okay, does everybody remember this? Of course, we need to write that insert by time, and so ILO runner insert by time a runner. Okay, and so here we have insert by time runner R. Okay, and this method, as we can see, it assumes that this list is sorted by time. Okay, so can anybody recall how we wrote this insert method? Insert this runner into this list. Can anybody recall what was our logic for this method? Yes?
If the runner comes before the first of this list, then create a new list with the runner first, and then sort the rest.
This list. as the rest.
Yes.
Okay? And if not,
And if not, then insert the runner in the rest of the list.
okay, and what do you return? You're correct. You corrected everything you said. So there are two cases. We have to find out whether this runner comes before this dot first, or the runner comes after this dot first. If the runner R comes before this dot first, then we return a list that starts with this runner, followed by this list. But if this runner comes after this dot first, then the list we want to return begins at this dot first, followed by the list obtained by inserting R into the rest of this list. Okay? So that's quite a mouthful, but in code, it appears as two cases. Oops. If, and now we wish to find which one of the two comes first. Okay? So we are in const low runner. The parameters of type runner. So we can't directly access r dot pause, r dot time. Even if we could not access this dot first dot time because that is a field of a field. Okay. So we say or finishes before. Does r finishes before this dot first? If r does finish before this dot first, then we return a list that starts with r, followed by this list. Okay. If r does not finish before this dot first, then we return a list. Oops, there's a new there. That line looked oddly short, and I know why. R followed by this. Otherwise, a new const low runner that starts with this dot first, followed by the list obtained by inserting R into the rest of this list. Okay? The empty cases are simple. Let me quickly write them. Public ILO runner, sort by time. The result of sorting an empty list of runner is an empty list. The result of adding a runner by time to an empty list is simply a list with R in it. R followed by empty. Okay, so here's the implementation in the const case and the empty case. So none of this should be new, but are there any questions? Yes.
Can you explain what you're returning in the if statement of returning
Either case.
um, the um, the if statement, the line right under it.
Oh, this one.
Yeah.
So imagine you have a list of runner that is sorted by time right now. Okay. And so I'm checking if the runner that I have to insert finishes before this dot first. So imagine a list that's sorted. And now I'm asking, hey, in this sorted list, I'm comparing this runner that I'm inserting with the first thing in this list. Okay? If the runner finishes even before the first thing, it means the runner finishes before all the runners in the list. So the list that I should be returning should begin with R, followed by the rest of this list. Such a list will be sorted because we just established that R finishes before first, therefore before everybody else, and everybody else is already in the correct order. So therefore, I return a list that starts with R and whose rest is this entire list. Okay? If that is not the case, it means, well, whatever is the first of this sorted list, the runner R is somewhere after it. Okay? So the resulting list definitely starts with this dot first. But then what follows is the result of adding this R somewhere in the rest. Where, I don't know, but somewhere in there. Does that make sense? Okay. Other questions? So this is fine. We have seen this several times. However, there are several ways in which we could arrange this. For example, I want to take a list of runner, and this time I want to sort them by their names. All right? And so I would write a method called ILO runner sort by name in the interface. I would implement it like this. The sort by time would become sort by name, and then the insert by time would become insert by name. Okay? Coming to the insert by name here, once again, I want to know if the name of the runner R is before in alphabetical or lexicographical order than the name of this dot first. Okay? And so here I would have to use a different helper on the runner class that says is name before. Okay? And then I would pass in this dot first, and if so, do this, otherwise do this, and then insert by name over there. So we see that a similar situation is brewing up that we saw last time. We could write a sort by name, and even though they are not identical, their structure is very, very similar. Okay? That's what happened to us when we were writing these two methods. We saw that those two were structurally identical, but they use different helpers on the runner and then did kind of the same thing. Okay? And so in order to avoid repeatedly writing these sort methods, what if we could write a single sort? So this story will follow a similar pattern as the story last time, which is, well, what is different from sorting by one criterion versus sorting by another criterion? And what is different is this thing right here. Given two runners, we wish to find out if the first runner comes before the second runner in terms of time. Okay? And so once again, we can convert this into a higher order function. What we intend to do here is compare two runners to see which one comes first. So this is a little bit different from last time. Last time, we just wanted to run a test on this dot first. There was only one runner involved. Now there are two. Okay? And because there are two runners, using a predicate like we have, using a predicate on a single runner is not quite going to work. So something like this isn't going to work. We still need a method that returns us a Boolean, but this time instead of one runner, it's going to have two runners. Okay? And so let's write such a helper. This time we won't go through the whole pace, all the paces of figuring out what we need, because we already know what we need. We need an interface. And I will begin with I. We need an interface that compares two runners. Okay? We need it to be a Boolean according to how we want to use it. I'll call it still apply. Or no, I'll call it is before. Okay? And now there will be two runners. Okay? Now to compare two runners by time, I would have to write compare runners by time. I'll make this implement compare runners. Okay? And so public Boolean is before. Okay? Let me rename that method so that it's named a little bit better. In some ways, I want to find out if the first runner is in whatever ordering less than the second runner. Okay? And so I will have a less than that takes in runner R1, runner R2. Okay? And once again, here I have two choices. Either continue to use that, continue to have a helper inside the runner class. So I can say either return R1 dot finishes before. R2. I can say this, or I can break my own rule and say R1 dot time less than R2 dot time. Okay? So that's sort of the function that I write that takes in two runners and tells me whether the first runner is less than the other runner. In this case, less than by time, by the finish time. Does everybody understand? Look over the previous lecture and kind of compare what kind of a function we are writing now versus what kind of function we wrote before. The before one just was a test on one runner. This one is comparing two. Yes?
Which of those two ways?
So way number one is design-wise better. Way number two is in some ways shorter. It has another advantage, but we have not seen enough yet to know that it's an advantage. So I don't want to give it away now, because if I give it away now, it seems like, okay, all our rules are meant to be broken. Okay. On the exam, on the assignment, you can do either one of those, because I think the lecture notes itself does this. So it's okay. All right. Let's see, Luke. Why do you need to wrap runner by time with another interface instead of passing runner by time class directly to the parameter of sort by? Yes, we did cover this last time, but I will say it again. Let me complete the surgery first of this method. Okay, so now I don't want to write a sort by time, a sort by name, and so on and so forth. So I will write a sort. Okay, but it is going to take in that object. So I convert my sort into a higher order function. And so, Luke, I'll come to your question in a minute, but for now, I'm going to use the interface. I compare runners. Okay, so that's my signature. And then right here, instead of this, I say this dot rest dot sort. So sort the rest of this list using this comparing object. And then to it, insert this dot first using this object. Okay? Because if you think about it, it's really that insert method that is going to use the comparison between two runners. So then this one becomes insert this runner using this function or the function inside this function object to compare two runners. Okay? And then this is replaced by if comp dot less than, and the two runners I'm comparing are, and this dot first. So this method will return me true if r is less than this dot first. And if so, do this. Otherwise, it's going to be insert r using the same function object. Okay? So, just going through and seeing how we will use this, just as before. Here was our example. All runners equals, and here's where you make together the list. And now runners by finish time. So it's arranged by finish time. Okay. Earlier, I said all runners dot sort by time. Okay. Now, I will say all runners dot sort, and then here's the function object I would like it to use. Compare runners by time. That's what I called it, right? Yep. So that's how I would call it. Now, I would call the sort and pass it this function object. It's still a function object. This object contains exactly one function in it. However, this function takes in two parameters of type runner and continues to return a boolean. Okay. Now, if I wanted to instead get a list of runners sorted by name, then no problem. I would say all runners dot sort. And now I would need to provide it with a function object, compare runners by name. In order to make this work, I would have to write another class, compare runners by name, that implements I compare runners and implement the less than method. And then here, I would have to compare them by name. So R1 is less than R2 if the name of R1 appears lexicographically before the name of R2. Okay? And so how do I know if the name of R1 appears lexicographically before the name of R2? The name is of type string. So if you go hunting in the string class, you will find a method called compare2 that provides the lexicographical order between two strings. And so that's the method I will call in here. Instead of saying R1 R1.time less than R2.time, I will say R1.name.compare2 R2.name less than 0. And to find out why less than 0, read the documentation for the compare2 method in the string class. Okay? Now, Luke, to answer your question, if we did not have an interface that unified these two function objects, then I would have a problem trying to write the signature of that sort method. Because I need a type for the function object in there. That type has to be such that I should be able to pass in one of several kinds of function objects, all of which take two runners and return me whether the first runner is less than the other. So if I just type a class name in there, and this sort method is good only for that class. And so if I wanted to sort by name, this will not work. Okay? So you can think of your function objects in this case as being another union type. A comparing function object is one of compare by time, compare by name. Okay? And so that's why we have the interface type over there in the sort. All right, other questions? Yes?
When you call runners by finish time,
Yep.
you call it with new compare runners by time. Why do you do that instead of like I compare runners, like the interface type?
Here, you mean when in the examples?
Yeah.
So in the examples, think about it. I need to call the sort method. The sort method needs exactly one parameter. The parameter should be of type I compare runners. So I need an object of a class that implements I compare runners. Because I need an object and I cannot instantiate an interface. There's nothing there. I must create an object of a class that implements that interface. Does that make sense? This is similar to we wrote the sameness method. S1 dot same shape S2. So the same shape method took one argument of type I shape. And so what I need to pass in there is an object of a class that implements the I shape interface. This is the same thing. All right? For all of you who like lambda functions, how would we write this? We could say all runners dot sort. Let's start cutting the red tape. So that new compares runners by time. It's just a gift wrapping for the method that's inside. What's the method that's inside? It's called less than. Takes in two runners, returns a Boolean. Okay? And so the name of the method is not important either because this object contains only one method in it. That method takes two runners. So I'm going to say R1, comma R2. I have two arguments, so I must enclose them in parentheses. Then the hyphen less than, greater than, sorry. And then compare runners by time is R1 dot time less than R2 dot time. And that's it. Okay. What I want to do with them can be expressed in exactly one line of code. That line of code evaluates to a Boolean, and I simply want to return it. Okay. This is the exact same thing that we ran into last time. We want to, there's only one thing to do here. Get the field that happens to be a Boolean and then return whatever it was. And so we simply could omit the braces in that case. So similarly over here. Okay. This other one, we would just say R1 comma R2 and then R1 dot name dot compare to R2 dot name. Okay. Or if you had a helper, R1 dot name before R2. That's fine. Whether you directly accessed the field of the parameter or you relied on a helper does not change how you, whether or not you can implement it as a Lambda function or not. You can just call that method. All right. As I said last time, short, terse, but subjectively better. So if you like Lambda functions when used well, they can shorten your code, make it terser. The happy byproduct is it seems to match the way we wrote purpose statements in Fundies 1. But if you don't like them, if they're confusing more than illuminating, feel free to do it the first way. They bring absolutely nothing new to the table that you couldn't do without Lambda functions. Okay, yes?
If we were using the Lambda functions, would we need to create all the classes?
If you were using the Lambda functions, you would still need to have the interface. You would still need the method name, full method name in there. And that's because in the insert method, you would be calling that method by name. So you need the interface name. You need to name the method in that interface. You do not need to write the class that implements that interface. Therefore, you need not name it. You can directly type it over here like this. Okay. All right. Now, this method works, but it's kind of a little bit limiting. Not really, but it's doing things that could be done better. Luke asked, the function object argument must have only one method inside for Lambda syntax to work, right? Yes. Again, think of it as if there was only one student in class, I wouldn't need to know the student's name. I can just say, hey, you, and there would be no confusion as to who I'm talking to. Similarly, any object that has exactly one method in it can be replaced with a Lambda function. This is not Java, this is Lambda functions. You can't have two functions in something and then not name them. You can't tell them apart. Okay? All right, so as I was saying, this method less than kind of does its job, but it can be better than this. Because something that it does not tell us is given R1 and R2, given two runners, did they finish at the same time? Are their names exactly the same? Okay? And to see this limitation, think about the return type. It's returning true and false. Okay? So if it returns true, that's it. R1 is less than R2. No ambiguity. But if it returns false, then that could mean one of two things. Either R1 comes after R2, or R1 is the same as R2. and the method doesn't really disambiguate which one it is. So it's a fundamental limitation of the return type that we happen to choose. Because when you compare two things, the results can be one of three things: less than, equal to, or greater than. But the return type we have chosen can do only one of two things. Okay? Yes? We can. In fact, before we do that, it is possible using less than to answer the question greater than or equal to. Okay? You just can't do it with one call to less than. All right? Here's how. I give you A and B. If A less than B is true, that means A is less than B. Okay? If A less than B is false, then if B less than A is true, then we know that A is greater than B. But if A less than B is false and B less than A is also false, that could mean only one thing. Otherwise, A is equal to B. So what this shows you is by just having a method that called less than, you can invoke it multiple times to get all three results out. So that's why I said this method is not wrong, it's just limiting because it doesn't answer that question in one step. You can still kind of squeeze out the comparison that you want by just looking at one method, less than, that returns a Boolean. You just have to invoke it multiple times in order to get how exactly they compare to each other. Does that make sense? But it would be better if we write a method that you call it once and it tells you exactly which one of these three cases it is. Okay? And so we need something that returns us one of three values. And that's kind of a weird thing, because if it was one of two values, we have a data type for it, Boolean. Okay? We don't really have anything inbuilt that has exactly one of three values. In OD, you will learn of a type, a custom type that you can define that will make you return only one of three values. But that requires you to define a new custom type. So a bit of an overkill in this case. Okay? And so what we can do is repurpose an integer, as was suggested, so that it returns us three things. All right? Now, we have to be careful about this because an integer can have many, many different values. We do not want to be in a situation where we say, okay, if it returns 1, it means less than. If it returns 2, it means equal to. If it returns 3, it means greater than. Because there's the very real possibility of somebody wrote a function that was supposed to compare two things and it returned 5. And now we don't know what 5 is. Okay? And this limitation is because the data type you're using, int, is capable of a lot more different values than the number of values we are interested in, which is just 3. Okay? And so we define this method in a slightly different way. We still use integers. So I'll call it compare runners 2. I'll call the method compare because that's what it really is doing. It's no longer answering is A less than B. It is comparing A and B. Okay? It is comparing two runners. So that part remains the same. And I will make it return an int. All right? But then I have to, as part of the interface, define what return type values actually mean. So compares two runners, R1 and R2. If R1 is less than R2, then we divide all the possible values of integer into 3 bins, so that we never have a case where a method like this returns a value and we don't know what it means. We never have the case where we're looking for 1, 2, and 3, but it returns us 5. Okay? So we say if R1 is less than R2, this number, this method is going to return us a negative number. So we take all the integer numbers and we create 3 bins out of it. All the negative numbers in one bin, all the positive numbers in another bin, and the only thing that remains, which is 0, into the third bin. So we'll say if R1 is less than R2, this returns a negative number. If R1 is equal to R2, then it returns 0. If R1 is greater than R2, then it returns a positive number. Okay? You see the design with this? Now, an implementation of this method cannot return an integer for which we do not have a meaning attached to. All right? So here's the compare runners too. Compare runners by time 2 implements I compare runners 2. Yes? Why is this stuff? Sorry? Why did we write all of this in an interface, or why does?
Why is there like an runners?
So I'm writing it as a separate interface so that we can compare and contrast what we had before versus what we have now. Okay? What we had before was just less than. Now I'm trying to create a supposedly better version of that, and so I'm having an I compared runners too. Okay? And so here now we must return an int compare runner R1 runner R2. Okay, now let's see. Here we had R1.time less than R2.time. That evaluated to a Boolean expression. Here we can say if my pen literally ran out of ink. Hold on. Something happened. All right, it's back. If R1.time happens to be less than R2.time, then return -1. Okay? I just arbitrarily chose a negative number. You don't have to return a -1. You can return -1251. Because all that this method says is if R1 is less than R2, you return a negative number. Which number it returns is not part of the purpose. Else, if R2.time happens to be less than R1.time, that means R1 is greater than R2, so I must return any positive number. I decide to return 1. And if it is neither of these two, then I return 0. Okay? Now, once I have this, I can make my sort method use this one instead. So I can make it return. I can make it take an I compare runners 2. And here I compare runners 2. And now this one will change slightly to if comp.compare R and this dot first. I'm interested in knowing if R comes before this dot first. So what I want to check is, does this method return me a negative number? And that's how it will change. Okay. You can continue calling it by new compare runners by time 2 if you want. And then in lambda notation, all runners dot sort. I still want to be able to take R1, R2. This time I want it to return an integer. And so I would have to type that entire thing in here. This entire if else in there. In here. So you be the judge of whether the lambda function is such an attractive option in this case. It's going to be a multi-line lambda function. It's pretty subjective. I would say it's no longer as terse or nice as it was before. But it's still not too bad. You could clearly do much worse. Okay? Does everybody understand the subtle difference between those two interfaces, between those two function objects? This one I can just call compare once, and it tells me exactly whether they are less than, equal to, or greater than. I don't have to repeatedly call it to get the exact comparison. Make sense? Questions? Let's see, somebody has their hand up. Shailin. Nice.
Yeah, so for our compare runners 2, since we just wanted to return like any negative number, any positive number, is there a particular reason why we like split it into 3 cases and did like a distinct value, like -1, +1, instead of just saying like R1.time minus R2.time?
Excellent question. So the suggestion was, hey, if all we wanted this method to do was to compare R1.time and R2.time and return a negative, positive, or 0, and we didn't care which number we returned, why can't we just return the result of R1.time minus R2.time? Let's review. If R1.time was indeed less than R2.time, then R1.time minus R2.time would result in a negative number. If R1 was indeed greater, then R1.time minus R2.time would result in a positive number. And if they were really equal, then their difference should be 0. So it turns out that we can indeed shorten it this way over here for this specific case. So why did this become possible? It became possible because the method we were writing returns an int. We are only interested in the sign for that int. And the thing we were using to get that result also happened to be integers. And therefore, the arithmetic between those two fields directly gave us what we wanted to return. Okay? So it's a happy coincidence. In this case, we can make it work if we had to. Okay? This is not going to work in all cases. So you need to be very careful. This is not even going to work in all cases where the numbers that we are supposed to be comparing happen to be integers. There are cases where even that will not work correctly. Okay, That's a subtle case. And so going forward, what I would say is write it out like this, make sure it works, and then think about, hey, can I shorten this without sacrificing correctness? In this case, I believe you can. In others, not so much. All right. So let's use this newfound function object that we wrote to write a new method. I want to know who won this race. Okay? Who crossed the finish line first? This corresponds to the runner in this list that had the smallest finish line, the minimum finish line. Okay? So I would like to find out who won this race by finish time. Now there are two ways to handle this. The easiest way, kind of piggybacking on what we just did, is, well, if we have a way of arranging all the runners by their finish time, then we do so. And then the first thing in that list is going to be the one with the minimum finish time. Right? And so if we implement it that way, it actually ends up being quite nice and short. So public runner winner. And so we can say, well, first I'm going to sort by compare runners by time 2. Okay? And from there, I'm going to get the first run. Okay? Notice, it's the first method. It's not first as in this dot first. That one I can't do because that's an ILO run. So this requires that I write a method called first, which is not difficult at all to write. It would simply return this dot first. So this is the cons case. The empty case. What should we do? What should the empty case do for this method? Let's see if somebody other than Luke can answer. If not, I'll give you the chance to answer, Luke. How should we implement this method in the empty case? What is the purpose of this method? Return the runner in this list with the minimum finish time. Okay? What is the runner in this list with the minimum finish time? This list being empty here. So the runner with the minimum finish time in an empty list of runners is, finish that sentence for me. Luke, Ivan, sorry, Ivan, go ahead.
You could throw an exception
Why?
because there are no valid runners.
Good. So the runner with the fastest finish time, with the minimum finish time in this list of runners is, and the way you complete that sentence is by saying, I can't answer that question. Because there are no runners, therefore this question makes no sense. So you want this method to say, I can't answer that question, rather than actually returning an answer. And we know the way for it to do that. We want this method to bail out and say, I cannot complete what you asked me to do. And that would be an exception. The question is, what kind of exception? This is not quite an illegal argument case because there are no arguments here. Okay? So we will use a more generic type of exception that exists. It's called a runtime exception. This is a sort of a Swiss Army knife of exceptions. It's not as specific as you want it to be, but you can make it happen. Okay? The first will similarly get me the first thing in this list. I'm sorry, I can't answer this question. There is nobody. Runtime exception. Okay? Now, this way will work, but it seems wholly inefficient. How many runners in the Boston Marathon? I don't know, thousands. Okay? You're going to sort the entire list of runners just to get me the winner? Surely there's an easier way. The easier way is this. You get them all in a line. Oh, wait, they already are. It's a list of runners. And then you say, what's your finish time? All right, 2 hours. Is your finish time less than that? No. Is your finish time less than that? Yes. Okay. So from here on, you're the winner unless I can find a runner in the remainder of the list that happens to have a finish time less than yours. So it seems to me that you can go through the list, and at the end of going through the list, you know exactly who the winner is. That's how we would naturally solve this problem. Okay? So think about how you're going to do that. It's a very short method that we'll write next time before we move on. Okay? That's it for today.